Hey everyone, my name is Matan, and I'm from Lightblocks Labs, that building the Eoracle network. Excited to be here with you and share a little bit about the perspective of building an AVS and how things are changing in the risk-taking world.
And I'm Vreeland. I am the Chief Strategy Officer at Polyhedra Network. We are a zero-knowledge infrastructure company with a focus on interoperability and scalability. And most recently, we have announced that we are launching a bridge between Bitcoin, the Bitcoin ecosystem and the Ethereum ecosystem, which is we're going to get into a little bit later as to why we are also becoming an AVS.
Yeah, so I'm pretty sure that everyone here are quite familiar with what is risk-taking and what is eigenlayer and how this basically allowing us an extension of the base layer of the Ethereum network into other use cases. And I think that we are here talking about the two most anticipated use cases as bridge as an Oracle that both clearly achieved product market fit in the crypto space. Most of the dApps that we know today have, and the chains, are using both of them. And I think that in the near future, we're going to see a lot of different use cases of AVSs. Many of them will be completely novel and new, and we're going to see if they will achieve product market fit. And some, like the one that we are about to discuss here, have this clear traction. And what we are discussing is how can we remove some trust assumptions when we are using a bridge or when we are using an Oracle and go back to either cryptography on your side or go and try to share the same trust assumption that anyway we are agreeing to when we are building on top of Ethereum or on top of a layer 2 that work with Ethereum.
Yeah, thanks for the alley-oop there. So, you know, if for those of you that aren't familiar with Polyhedra or our primary product, which is ZK Bridge is our zero-knowledge interoperability protocol. Currently, it's deployed on about 20, 25 different EVM chains, and it uses zero knowledge to generate a proof of the consensus and state of the sender chain. It sends that proof to the receiver chain where that proof is verified, and then the message is sent, the corresponding action is executed. Where we really, I think, came up upon a roadblock was when we started to think about interoperability between Ethereum and Bitcoin. Because Bitcoin doesn't have smart contract functionality, we needed to think of a unique way to solve this problem. How can we secure this bridge without using a traditional setup? So most interoperability protocols that you might be familiar with, you know, they have a validator network or what they might call a guardian network, and it is, you know, a group of either sometimes it's internal validators, sometimes it's external parties that sign off on these messages as valid. And you know, sometimes there's some economic stake, sometimes there's some reputation stake. And from our perspective, we're always trying to build towards this core ethos of trustlessness, which may not be possible, but trust minimization is the goal here. And I think as an AVS, you're able to, or we were able to kind of tap into this, not instant, but relatively fast security of a lot of these restaking tokens, and also add utility to our own token to secure this bridge between Ethereum and Bitcoin. So for us, we're moving, you know, data from one chain to another chain. I know you guys are moving data, you know, from off chain onto chain. Why don't you talk about kind of your experience setting up your AVS, or I know it's still in process, but kind of what are the things that you guys are thinking about as you guys are getting ready to launch on mainnet?
Yeah, so starting from what you just said about minimizing trust assumption, as we cannot eliminate all trust assumptions, but in essence, this is why we are building in this space. Like everything that we are building here can be built in Web 2, but we have this added dimension that is very crucial to keep it in mind in everything that we are building, that we are not introducing new trust assumptions. And for middlewares, up until today, that wasn't really possible. When you introduce a middleware, you basically inherit these new trust assumptions. And in our case, when you think about the Oracle problem, you have this off-chain to on-chain connection that you have to rely on the entity that provide you this data. And we have existing Oracle solutions that are working very well and constantly keep improving on latency in terms of the pace of the update and maybe the cost of the update itself, but forgetting about this essence of minimizing trust assumptions and actually adhering to the standard of decentralized networks. So that was the one thing that brought us to understand that there is a paradigm shift here that's happening through restaking that allow us not to just improve on how oracles work, but actually to step back and to say, what if we can do this thing in a completely different way? What if instead of launching a new network and asking dApps and the ecosystem to trust our network because it's better than Chainlink or it's better than any other Oracle system, what if we can connect the base layer to this additional task in a direct manner? And this is where we started our journey, and now building an AVS with that in mind means that in every part of the architecture, you have to make sure that you are not introducing some kind of a single point of failure or systematic dependency on how we are building it. I think that we are one of the first teams to start building on top of EigenLayer. We are doing that for over a year now. If you would look in our architecture, everything pointing out to the fact that this needs to be completely decentralized in governance, but also in the operation of the Oracle itself.
Yeah, I think we've also been working with EigenLayer for, well, I guess not a super long time, because we just kind of thought about this project maybe a couple months ago. So our journey has been a little bit different in that we kind of identified this problem that we wanted to solve. We started talking to different teams that are building in this space, that we wanted to collaborate to bring this vision of interoperability between Ethereum and Bitcoin to life. EigenLayer became an obvious choice. But I think one of the things that we saw is, as soon as we started talking to EigenLayer, because it is a permissionless system, you have all of these other projects that are immediately accessible to you. You have LST or RST projects that are coming to you and saying, hey, we want to add hundreds of millions of dollars of security to your system. You have node operators that are coming asking to help kind of secure your project. And so it's not just the ease of setting up an AVS, but it's kind of that partner network as well. And I don't know if you had a similar experience working with them.
Absolutely, absolutely. I think that we have many different entities in the blockchain ecosystem that understand that this is a big shift, and we're stepping into this new ecosystem while we have all of this support, as you are saying, from operators like Dora that hosting us here are an operator in our network, and multiple LRTs that really help in terms of onboarding liquidity into this new ecosystem. But in essence, the goal with all of them is to make sure that this partnership are being built on these values that brought all of us in.
And I don't know, I think I heard from the last panel that was up here, one of the alternatives to kind of starting an AVS or building an AVS is, you do have the opportunity potentially to launch your own blockchain or launch your own L2 to tap into the security of Ethereum. Was that something that you guys considered? Maybe talk through kind of the alternatives to building an AVS and the pros and cons that you guys weighed as you were going through that process.
Yeah, so I think you can break down AVSs into two major groups, blockless and blockchain. And some AVSs that will be considered as light AVSs will not need their own chain. while others that do want to make sure that all of the activity, in essence, is being registered in some kind of an immutable ledger, as we like to call blockchain, do need their own chain. In our case, we are building a blockchain that is already live for quite a few months now in an initial testnet phase. And our operators are, all of their activity is being registered on this chain. So we are able, in essence, to track which data has been collected by which operator, and then later on, kind of do the accounting of the rewards, and also make sure that we always have some kind of a reference if something goes wrong, to know that there is some kind of punishment that need to go into the picture here. And in the initial phase, we're not going to have slashing probably for, let's say, the rest of this year, but we are here to build this kind of a way of not just to deter malicious activity, but also to have a cryptographic way of proving that a slashing event needs to take place.
So it's not, I guess this blockchain is not necessarily used to secure your oracles, but really used as a mechanism to determine kind of what went wrong or where something went wrong.
Yeah, so accounting is a big part of it, as I just said, but in addition to that, for us to be completely modular, we separated the two major aspects of an oracle, which one of them is to fetch data off-chain, but the other one is to do compute on this data, to do some kind of an aggregation method that will turn this data into something that you can use on-chain. Now, this aggregation takes place via smart contract, completely on-chain. So this is not something that we expect the operators to do, and by doing so, you also simplify the operator work and lower the barrier of entry, which means that you can bring in also home stakers to do the same work, and all of the computation is happening on-chain. So all of this computation is taking place on smart contracts that anyone can come in and define, I want an average of this data, or I want a weighted median, or maybe I want a completely new aggregation module that can be defined on a smart contract, and you know that you don't need to trust any of the other entities in order for you to verify that.
I think for us, one of the biggest advantages of kind of going with an AVS and going with EigenLayer is, you know, especially with interoperability between Ethereum and Bitcoin, and then potentially interoperability between Ethereum and other networks, is that we don't want to just rely on Ethereum to secure the network. We want to rely on Ethereum and potentially Bitcoin down the road, or Ethereum and the ZK token, and setting up an AVS and utilizing kind of the dual staking functionality or this ability to stake different tokens to secure the network was something that we were really excited about. I'm curious, like what other functionality you think was unlocked by the AVS that maybe surprised you when you first started working with them? Yeah,
so I think that a major thing, and you touched it briefly before, is that we are passing the bootstrapping problem. All of us here know many different networks that exist in the space, many different blockchains and projects that need to set up their own validator set, and this is probably one of the hardest things to do. How do you find a group of unrelated entities around the world that you don't need to over-incentivize to start running your software, and you want to kind of get to the point that this network is decentralized over time, while you have this group of validators that as of today there are over 1 million validators registered on the Ethereum network. Tapping into this group have enormous value, and early on we didn't fully realize how useful this part will be, not just the stake, not just the capital, but also who is behind this capital and who is actually operating this. So I think that this is something that even today, most AVSs don't realize how big is this problem that we don't have to deal with.
Yeah, I think I keep coming back to it, but for us it was, yeah, it solves a lot of the problems right out of the box. So it made development super easy. I guess we kind of jumped into straight into the AVS stuff, but maybe we could take a step backwards for a second and just talk about your product and kind of who you're building for and what you think it enables for the end user.
Awesome. So our space is constantly moving, and we are seeing many different roll-ups that coming up online. Like the Appchain thesis said that a few years ago we had thousands of applications living on top of Ethereum and on top of like the big main chains, and we are now in this constant progress where application-specific chain is the way to go, and we have stacks and we have roll-up as a service that really enhance this process. But this also comes with major infrastructure needs, like bridging and oracles and data availability that need to support all of these roll-ups. Oracles, as we know them today, not just come with this additional trust assumption and systematic risk, but they also come with a certain cost of integration and friction in this entire process. We believe that when you launch a roll-up on top of any kind of a layer 2, you can have an Ethereum Oracle integrated at Genesis that you can start with. And this Oracle shouldn't just be an out-of-the-box tool that do this specific one thing, but it should be a modular and programmable way of you to interact with the real world. In the same way that you can define your own smart contract, you can define your real-world interaction. And this is the promise behind Eoracle and what we are doing.
Cool. And I thought it was really cool when we talked earlier, you know, that we are kind of solving similar problems in that you guys are moving data, you know, off-chain, on-chain to make it available for developers. We're moving data from one chain to another chain to make it available for developers. And at the end of the day, I think, you know, one of the problems that we're also both trying to solve here is this liquidity problem. So, you know, when applications are choosing where to build, you don't, or from our perspective, you know, you don't want, it's a big decision to choose one chain to build on. And so, you know, by utilizing either Polyhedra's ZK bridge or Polyhedra's interoperability protocol, or utilizing our ZK Lite client via layer 0, applications don't have to make that choice anymore, and they can choose to build an application that has functionality across multiple chains, and they're not kind of going to get stuck with a bad decision that they made in the beginning. I think similar to that you guys might be, you know, solving this problem is, you know, is the chain that I decide to build on going to have the data that I need? Because you guys are able to bring that data really anywhere in a manner that's secure and easily accessible.
Yeah, and I would love to ask you, what are you most excited about in the near future? We are simply in the beginning of a new cycle, and we are anticipating new things and exciting things to happen. Well, what excites you most?
Yeah, so I think after we've launched our BTC bridge, we took a step back and we realized that we've built all of these zero knowledge kind of developer tools, developer products that are really significantly faster, significantly cheaper than a lot of the stuff that's out there. And we've just gotten to a point where, from a computation perspective, from a speed perspective, from a performance perspective, utilizing ZK is starting to make sense. You can start to generate these proofs in an amount of time much smaller than block generation time, which makes its applicability to real-world use cases very apparent, and I guess makes it a good time to start building with zero knowledge. But we don't want everyone to have to reinvent the wheel. We don't want to have everyone start over. So we're going to start putting those products into the market. So starting with our Prover Cloud platform, starting with our ZK compiler, and then coming with our ZK virtual machine, we're going to start to release these products so that other developers who want to develop with zero knowledge can do so in a way that's just as easy as deploying a smart contract on Solidity.
That's awesome, because I feel like we're excited about the same thing, which in essence is enabling a whole new wave of innovation. In the beginning of the previous cycle, we saw a lot of new applications coming up online and new use cases that are really real-world use cases, right? We saw lending markets, derivatives, prediction markets that were enabled by these new technologies on-chain. And now ZK and what we are building in terms of real-world connectivity in a completely modular way, I hope that will be a big enabler, and we're going to see a lot of innovation in terms of new applications that can be built on chain for new use cases. And I think that, in essence, that's what should bring new people into the blockchain space rather than a new shiny meme coin.
Yeah, I think that's a good place to end it. I think we're both interested in kind of talking to the same developers. If you're building something new, if you have a need for off-chain data or movement of data on-chain, or just want to talk zero knowledge, come find us. We'll be around. It's a pleasure. Thank you very much.
Thank you.